LLM, RAG, SFT, AI agents, MCP. The AI world is throwing new terms at you every single week. And if you're nodding along in meetings pretending you understand the difference, don't worry, you're not alone. In this video, our mentor, Shri Prakash Singh, is going to break down all of these concepts in the simplest language possible. No jargon, no confusion, just clarity. Stay till the end, because I promise this will be the most productive 15 minutes you spend today. Welcome to BI and Data Science. Hit subscribe and join thousands on this AI learning journey. And drop a comment telling us what topic you want us to cover next.
From fundamental last time, we understood what are different types of model when you hear people talking deep learning, machine learning, AI, generative AI, and LLM. How are they different? Understood a mental working model of how a LLM works. Because no matter whether it is text or video or audio, process is very similar to the text thing, the language, how the text model work, even the vision model and the image model, they all work similar to text model only. If you understand one of this workflow, you'll know how the large language model works. The basic idea is whatever text we interact with AI, those texts are first tokenized. And after those texts are broken into smaller words or chunk or tokens, or they are embedded into some kind of vector representation. Then this vector representation is compared and modeled to get the similarity and the closeness of each word to other word. And it's a big prediction model. And actually those models are called Gemini or like GPT-5, right? These are the names of those models. So the estimation of how the embeddings should work so that you can predict things which are close to one and another, right? And that's why those models have something called parameters or weights. So we learned more about them. Then we understood what is a transformer mechanism, like how attention and context becomes important, and then how the prediction and final response is generated. So we talked about it. And then what these AI models do is they do it incrementally in a loop. First, they will take 2 words, then predict the third word. Now they have a string of 3 words. Then they will predict the 4th word. Now they have a string of 4 words. Then they will predict the 5th best word, and then it will keep on doing this in a repetitive manner until it comes up with the full paragraph that it wants to generate. So that is how the answer is generated. So when you type a question to ChatGPT or Copilot, predicting word by word by word, and then collecting everything, making it a phrase and sentence and paragraph, and then giving you the output. The better our prompt is, the better our answer is. And we learned about all these things, like what are each of them. And then we learned one very good way of thinking. I believe some of you are using it over the last 1 month. If you haven't used it, please refer to the video and use it, because this will give you much better output. Given that, I think today we will start from here. Prompt engineering is the basic thing that all of us use in our daily life. Like we should all be using. This makes us productive. But at the same time, now the thing is, all these models are still very generic. If you do a lot of prompt engineering, you will get good answer, but still your answer is not grounded too much into the organizational data. Why? Because you cannot make your prompt too long, right? There is a limitation on this AI, like how much information can you put in the prompt, right? So the prompt is limited by the context window. To overcome the limitations of prompt, there are 2 broad approach to make your AI more relevant to your enterprise. One is you can retrain or you can fine-tune the high-level generic model to your specific organizational data. So that is called fine-tuned LLM, and in short form, in terms of jargon, you will hear the words like SFT. SFT is nothing but supervised fine-tuning. Or you would hear the words like LoRA, low rank adoption. Right? Those are nothing but we are taking an existing model like Llama or Gamma, right? Any of these open source model or even proprietary models. And then after the weights of those models, we are further tweaking the weights. So in this whole process, the AI's model parameters what we saw earlier on slide 3 or 4, those weights are getting changed, right? That's why your model is becoming more relevant to your data, because the model weights are retrained according to your data. So the weights have changed and now it has become more appropriate in terms of your organizational context. In this model, when you fine tune, you don't need a lot of prompt engineering. So that whole exercise of being a better prompt writer goes away, because you have explicitly told model to readjust all its weight, all its regeneration capability to the very particular need of your organization or your workflow. Like, for example, we can retrain a model like Gamma or Llama for say customer support management. We can take customer support data and the training data for customer support, like you can take the call recordings or the chat of say customers over last 1 year, and then you retrain the model on last 1 years of your organizational chat data to make the model learn what kind of questions come in and what kind of answers the agents have given. And based on those answering and questioning style, the weights are now modified such that when you ask a new question, it will feel very much familiar with your organizational line or style of asking and tackling the question, right? So that's how these models are very fine-tuned. Now, the challenge with fine-tuning is it is very, very costly, because you don't have to only put infrastructure for the pipeline, but for training the model, we will need GPUs, right? So the models will run on a very large compute stack. So it becomes very costly. So we'll have to make data pipeline, we'll have to make the training model, and then we'll have to do the model validation and all of that thing, right? So it becomes very costly. The second problem is, if we are fine-tuning the model, then you have to keep fine-tuning after every 6 months. So there is a component of maintenance, because these weights might change as your business is evolving, as your customers' interactions are evolving. You might be introducing new product in your system or new services, and old services would be shutting down, right? So there is a constant change of knowledge in your internal database, and then models' weights are not optimized to the recent data, right? So you have to keep retraining the model, because this is already once retrained on your data, so everything is already tweaked. It is no longer the generic weight, and it is modified weight according to your needs, so you have to maintain it. So what do we do? The balance is, most of the organization, they follow a different approach, which is the RAG approach. Now in RAG, or the retrieval augmented generation, we do not retrain the model, we do not change the weights. So these things don't happen. Rather, what we do is we make an internal pipeline of storing all the internal knowledge in a database, and we store all the internal knowledge in the same way how these models were originally built. Remember, everything was tokenized and embedded and a vector was made. So rather than retraining the model, we take our organizational data and we tokenize our organizational data. We embed our organizational data. So what do? We kind of build a pipeline to have a very comprehensive vectorized database of our knowledge. And now, when there is a question from a user, rather than sending that question directly to a LLM and getting an answer, what we do is we first go to our knowledge base, which is vectorized, and we do a lot of similarity search, like what kind of knowledge exists in our enterprise for this kind of background or for this kind of question. And then we fetch all of that knowledge, and now we pass the LLM all the contextual knowledge that we have found in our database, right? So that way, we don't train it, we don't do a lot of prompt engineering, but by easy pipeline of ability to query our existing knowledge base according to context, and then enriching the LLM with that context to give a response which is generated after the augmentation of the organizational knowledge, is the RAG, right? So that's how a high level RAG. Is it clear now? Like, we share this time some slide that we go a little bit in detail, and we will learn today the agentic and MCP, so that we'll have a good understanding of that as well. Whatever we learn, now we are talking about 3 more things, right? The RAG, the AI agent, and the MCP thing, right? How does this all fit in the puzzle. Think of it as a funnel, right? So LLM, like the Llama model or Gamma model or the Sonnet model or even GPT o5 or o4, whatever the model they are, all the LLMs are like the brain. Like they are the thinking engines, right? They can reason, they can generate text response, a video response, audio response, but they don't have a lot of memory or context. So to enrich context, we do prompt engineering or we do other method of fine tuning or right, something like what a RAG is. Think of RAG as the library, right? So whatever data we have internally, we can collect all of that data and we can feed to the brain. So think of LLM as someone who is knowledgeable. He can reason and understand. And now we put that person in the middle of the library for him to learn everything related to a field or related to an application, right? So the RAG is that library component. Until here, if my LLM is learning from the library and it's still giving me responses, but I as an engineer have to go and do the task. Then until this point it's a RAG pipe. However, I can give the AI a hand. I can give him permissions to execute few things on my behalf. For example, you can give it access to your emails and then you can say, okay, based on your brain, based on the knowledge of my existing email existing email responses over last 1 year, which is my library, you go ahead and start writing auto reply emails for me. Then you have made your AI an AI agent because now AI agent is taking an action. It's auto reply. That is the only difference between an AI chatbot versus an AI agent. You are asking something and you are getting an information. But if you give that person, the brainy guy who has learned in the library, if you give that person hands to execute, that person is now an agent. So he is now making decisions. So he can do an auto reply to your emails. He can delete all the junk emails and he can flag spurious spam. So you can come up with a lot of use cases, right? When a bot versus agent. Now, when we are giving it permission, actually the hands are the permission or the access provisions, right? Now, these access provisions are mostly done using API calls. For example, if I'm connecting my chatbot to do an auto reply for my emails, I'm doing an OAuth integration with my email server, right? I'm doing a authentication integration with, say, Gmail or even 365, like Office 365. So all this provisioning or handshaking is the API calls. Now, different applications have a different protocol or a different format of the API incoming call and outgoing call. The idea was, can we standardize? Can we make these API calls independent of the context, independent of the format? Because our AI has the natural capability to understand any unstructured data or any language, can we make API language-based rather than key-value pair-based? Think of it that way. So that is nothing but a MCP server. So MCP server is a kind of it's a gateway where AI agent can go and they can ask in a free format, I want to connect with application X. You tell me what all information you need from me. And the MCP server can say, okay, you want to connect with email, you need these three things. Like you need the user ID, password, maybe OTP or some two-step verification thing. And then AI can go back, distill that information. Now you can tell all these things in a flat file to AI, maybe a secret key, right? How we maintain our secret words. So now AI can go read from your secret key and dynamically figure out like what key to give to what kind of API. All those configurations are automatically done. Like we are not required as an engineer to tell AI, hey, when you are talking with Gmail, you do this validation. If you are talking with AWS server, you do this validation. And if you are talking with, say, some other tool like web search, you give the port information and a lot of other things, right? When you are talking with the gateway, you have to give a lot more other information. So all of that standardization is done using the MCP server. So That's the basic terminology between an agent, a bot, and MCP server. Most of the tools that have capability to deliver you something using a protocol, in their internal working, they are doing all the hard lift. They are doing all the configuration and pipelining for you. Like, still, when they are calling the actual API, they are distilling the information, putting it in order. It's just abstracted from us, right? So MCP server is abstracting. So it's kind of the nervous system. We don't know how our hand talks with brain, or when we feel hungry or thirsty. How do we get the signal? We don't know, but the system works. So that's the whole idea. This was the basic workflow. This was the vectorized workflow that we saw in the augmentation generation, like by splitting document into a small chunk, creating that and then storing the embedding in a vector database. And then when a user asks a question, then we first go to our database and then we find the relevant context, we augment it, and we send that augmented information and user prompt and all the other prompt to the AI model, and then AI model generates the output. So that's a RAG pipeline at a very high level. Now, in an AI agent framework, as we said, right, we are giving AI the hands. Now, those hands can be the feedback, the planning, the database, connectivity to the tools, and other reasoning things, right? So these are all nothing but set of tools that it can access. And we can also give it a memory. We can give it a cache memory to store informations and recall, right? So here memory can also be of two types, like the short-term memory and the long-term memory. So a lot of these things are still evolving, like MCP and AI agent workflow. Like, a lot of things are still being underdeveloped by different teams and in different capacity, right? So these things are still in progress. But if we think about the MCP protocol as well, it's again standardizing everything, and nothing but MCP is that protocol which is enabling one agent to interact with other agent freely, sharing the information, and when they are talking with the tools, they can exchange all the required API keys and their values from the secret file and make everything seamless, work in a loop until the task is done up to a quality, right? This is basically the fundamental difference between Agentic AI, MCP, and RAG. And now the $1 million question is, we can build it or we can lease it.